So we're going to have the very first talk, lecture for the Chi-Feng Magnetic Society Summer School 2024. And it will be given by Professor Atsufumi Hirohata from Tohoku University. And before joining Tohoku University, he's been with York University for a while. And Professor Hirohata is now the president of Chi-Feng Magnetic Society. So he's going to give us his career aspects and journal editor's perspective, and then maybe talk a little bit about the students in magnetism. So let's welcome Professor Hirohata.
Okay, thank you very much. And I would like to thank Chi-Feng and also his team to organize this summer school in a very nice venue and very well organized program as well, and also Hyun-Soo to supervise their activities. So this is not a scientific talk, as you can see, and the purpose of me standing between you and probably night market this evening is to make sure I will set certain environment so that you can mingle together among yourselves. So this is nothing so formal, so just bear with me for 1 hour. And I will split my talk into 3 parts. So in between I will take any questions from you, and also if you want to ask me anything in between, please feel free to interrupt me. So I am currently in Tohoku University, and also officially from this year, as far as I can get my visa sorted out, I will be half-time in Max Planck in Dresden as well. So you are already in PhD course, and probably you are almost finishing your PhD course or at a certain point, and you may think about what you're going to do in the future. And I was once in the same situation many years ago. And you can think about your career path, and if you want to get a job in industry, the final goal may be you want to get the president of your company, and in order to do that you need to climb up the ladder, and it's the same if you want to stay in academia. This is statistics taken by the Royal Society in the UK. They said after the graduation of science and technology courses, so-called STEM subjects, more than half of them goes to careers outside science. And this is partially because the UK doesn't have much industry, to be honest. And that's why they go. Mainly, when I was doing a PhD, most of, all my friends got their first job in consultancy, because the salary at that time was already 3 times more than the postdoc salary, so that explains. And then half of them stays in science, and then they take the early career research, which means postdoc, and then afterwards they may do some permanent, become a permanent research staff, which means the lecturer in the case of the UK system, and then they may become the the associate professor or professor afterwards. And according to these statistics taken in 2010, only 0.5% ended up as a professor towards the end of their career. Of course, this figure is now a bit more improved because the UK also adopted somehow the US type system. So in the US, the situation is not so much different. Most of them goes to the private industry, and then about 30% goes to the stay in academia. And similar to the UK system situation, some of them, even after the postdoc, they may end up with industry, or some people come back from the industry. And it's the same in the US. Some people got their first job in industry and then comes back to the academia and so on. And this is the career in China, so most of them got employed one way or the other, and quite a few people got self-employed, and quite a few set up their job, new business. And the salary for the new graduate, this explains if you can get the higher salary, and then you will definitely take that job. So this is the statistics, I think, taken in 2 years ago or something. No, 2018. Large number of graduates got employed by Huawei and then ZTE or Tencent or other IT-related companies. And this is the situation in Japan. So the situation is quite similar. And in Japanese case, most of the students goes to at least this master's degree, which is very different from the, for example, UK system, because in the UK, if you are a graduate from, for example, Oxford or Cambridge, and then after graduating from your bachelor's course, and then if you donate certain amount of money to the university, you may get the master's degree. That's slightly different master's degree from the master's in research, but that's how the UK system doesn't really value the master's degree so much. But in Japan or in the US, master's degree is quite important to get the industrial job here. So as you can see, most of the people graduated from the master's degree got the job in industry. And then if you stay till PhD, like I did, ended up with academia because there aren't much choice in the Japanese system. So those are the kind of overview in various parts of the world if you are doing PhD. And this is a fun cartoon I found on the web. So when you started your PhD, you think your supervisor may be a genius, and you may think you will definitely follow whatever they said. And with time, you may find, oh, this guy may not know that much, because you are the person really doing research, and if you ask any questions, and then if the question is difficult, they may tell you, oh, I have to prepare my lecture, so come back in 10 minutes or 15 minutes, and that 10 minutes never comes. So you may get disillusions with time, so I can explain those based on my own experience. So when I did my PhD, because I had some argument with my supervisor, with my master's degree supervisor, so I didn't want to ask him to write me, I didn't expect him to write a nice reference letter for me, so I decided to apply a university abroad. So I went to Cambridge, and this is the Cavendish lab, and this was my supervisor, late Tony Bland, and he was a very nice guy, and he always said to us, he likes foreign students because they don't want to go home so often, and they tend to stay in the lab longer times than the British student. So the typical day of the British student, at that time, no offense to the current British students, so the students normally comes around 9:30 by bike. We call it bike, but it's a bicycle, basically. And then they chat with their colleagues, and then, of course, tea time is very important in the UK, so they have to go to tea for 1 hour. And then come back at 11:30 and check emails, go lunch at 12:30, have chat with their colleagues until 1:30, and then do some research, afternoon tea. So that is another important event of the day. So they spend another 1 hour in the canteen and then come back around 4:30. If it is in summer, they always said, oh, this is a nice day and it is quite unusual to have sunshine in the UK, so they go home. In winter times, they claim, oh, it is too dark, so they go home. So they, anyway, go home around 4:30. So I was wondering very badly how they can make any results or achieve anything. But before the conference, they work very hard, just for a couple of weeks, and then they get some results, and they give beautiful presentation. So I thought it is nice to be a British. But that was something I saw when I was doing my PhD. And then I went to MIT in the US as a postdoc, and at that time my supervisor was Jagdish Mudera, and he's still active in the MIT. And the day was very different, as you can imagine. Typically, we have to be in the lab before 9, so I usually take a bus because I didn't bother to apply for the driving license in the US. It was, first of all, it was very expensive to buy a car, and also the insurance was very expensive. So then we usually go for lunch around 12:30 individually, and then come back to the lab around 1:30, and then till 10 or so we do experiment. And most of the buildings are always light on, and it is probably not good for the environment, but who cares, basically. And once I was off, not off, but I was doing washing the laundry on one Saturday in the morning. And then I got a nice phone call from my supervisor asking whether I'm dead or not, because he was expecting me to be in the lab by at least 10 during the weekend. And I was a bit late because I was doing laundry. So that was quite tough life, and it's very different. And then afterwards I came back to Japan to do a postdoc in Tohoku University. And at that time my boss was Professor Hirohata, who used to work for Toshiba, and he was the leader to develop the laptop computer over there. So typical day in Japan at that time, no longer it is true, I believe, but we usually go to the lab around before 7 o'clock in the morning because we had some early start, and this is partially because I didn't want to get some rush hour and so on. And then around we have lunch, and then come back to the lab, do some e-beam lithography or something, go to canteen to have dinner, and then come back to the lab, do another measurements, go home around midnight. So that's not recommendable, but that was what I was doing when I was doing in Japan. So based on my personal experience, and if I compare with those three different regions, if you have come up with any nice idea, and then what you're gonna do? Depending on the regions, you may have different solutions. So in Japan or most of the Asian countries, the group is quite large. I don't know how large is your group, but usually you have a big professor, and then you may have some associate professors, assistant professors, sometimes postdocs, PhD students, master's degree students, and then bachelor's degree students. So everybody has their junior, sort of. So you always think about how to distribute your idea to army of people. So then you can plan your experiment or research by assigning a series of tasks to various people. And in the UK, or most of the European countries, if you come up with a nice idea, it is typically true in the UK. If you find a very big professor, sometimes they simply lock their office door completely for 2 weeks or so. so that they will not get bothered by any other people. So they think about how best they can design their research. So once a friend of mine, colleague of mine told me the best research is to do just one experiment and then write a Nature paper. I don't know whether that is okay or not from the reproducibility point of view, but he said that is the most beautiful experiment. So that's what they do normally, so they need some time to think about their research. And in the US, of course, you have to run to do the research quickly. And then you need to get the result. So in most of the Asia countries, because you have army of people, so you may end up with huge amount of data, which is very good if you are doing systematic research, for example, changing some composition of your alloys or changing some small conditions, measurement conditions, and so on. And in the in the UK or in Europe, you may be able to achieve very big step forward by thinking about your research plan very carefully. And in the US, you end up with, if you are top person, and then you end up with a patent or some support from industry, so you're going to become quite rich. So in Japan, people may write a very, very big systematic paper in the end, and that satisfies the researchers. And in the US, UK or Europe, they may become the leader of the field because they design the research and they took the lead. For example, the graphene or some other research is a good example. And in the US, people become very rich because they are very quick. So when I was doing a postdoc in the US, I had to see my boss every day, every week, every Monday, every week, to report how much progress I made. And if I failed to make any progress for 2 weeks, and then he said, okay, let's stop this project and move on to the next one. So that's how, I don't know how rich Jagadish is, but he never told me, but I'm sure he's rich enough to build some schools back home in India. So that's how different view you can find in the world. So you may not believe what I said, because this is purely based on my personal experience, but I have an example. So in York, it was the birthplace of KitKat, because when the Industrial Revolution happened, the workers in factories, they feel hungry, like you did 1 hour ago. Now you are completely full. So then, because those factory workers can have their hands very dirty with their oils, so they don't want to touch food directly, but they need something to fill their stomach. So that's how one of the chocolate companies called Roundtree in York developed this KitKat. And if you go to the UK or most of the European countries, you can find 5 flavors or 6 flavors, but still the most popular one is the original one. So this is the very first product after careful thinking. And if you go to Japan, you may end up with over 200 types of KitKat. So this is like a systematic study, in my view. Of course, not all of them survived because of the taste of the customers, but you can see how enthusiastic Japanese we are to develop new flavor. And if you go to the US, you hardly find KitKat because the most popular ones is Reese, and then Snickers and so on. So from the sales, worldwide sales point of view, Reese comes first, and then Snickers, and then the third position is KitKat. So as I said, the American people are very good at making money. So that's how I try to convince you. Now, that's the end of my first part, so if you have any questions or criticism or any suggestions, I'm happy to take. So, any questions or comments? Yes?
How did you survive the Japanese staging? Because I remember that you said like you guys start working at 6:30 a.m. and up until like 12, I think it was there. So
I think the efficiency wasn't that high. We were talking with each other and having some tea in the office and so on. But it was a very good fun because luckily the group I was in was quite large. So there were about 20 students with 2 postdocs, 1 assistant professor and 1 associate professor. So we had a good chance to talk with each other, and especially different people has completely different topic. Associate professor was specialized in permanent magnet, and I was doing Hoyzel alloy development, and the others are doing some high frequency measurements and so on. So whenever we talked with each other, we get something interesting learned. So it was quite useful, but of course we are not working continuously from 6:30 till midnight. Yeah.
So in your personal experience, not something general, which one did you like the most?
Well, that's always a difficult question. I think each strategy has pros and cons, as you can see, and it is always a balance. And also, from my personal perspective, it was good to learn these 3 completely different working ethics or working environment, because then I can find out each student is different, and then they may have slightly more Asian type working style or American type working style or European type working style. So it is relatively easy for me to find out who is suitable for which strategy. Yeah, thank you. Any questions? Yes?
What makes you choose academia at the end?
Well, to be honest, I wasn't good enough to apply for industry. I wasn't so clever. So all the nice jobs were already taken by my colleagues who are much cleverer. So I ended up with academia. That doesn't mean all the other lecturers are in the same position, so I'm probably the black sheep in this room. Okay, thank you. Any other questions or comments? If not, I will be anyway around throughout this week, so if you have any questions, feel free to ask me. So let's move on to the second part. I've been working on various journals, partially because as I have my very proper Japanese background, so I cannot say no if I've been asked by somebody. So I've been doing some editorial works for these journals, and I can give you some suggestions or some tips based on, again, my own experience. So when you write a journal article, I'm sure you know this already, but it is always nice to start with maybe some representative figures, and then you think about some nice explanation flow so that you can make some story out of your results. And then discuss your results, add some conclusion or summary, and then you add the corresponding procedures, experimental procedures or modeling procedures, and then write the introduction at the end and add the abstract and decide title and who contributed to your work and so on. And then you will submit your paper to some journal, and then before submitting your journal, I'm sure you will ask your supervisor to read it. but also make sure you read your own paper as if you are a referee of your paper. So read it very critically and then give critical questions, and that will be very good training for you to read other people's paper and also review the other articles in the future. And then after being reviewed, be kind to the reviewer. I know some people who can be quite aggressive to the reviewer. I cannot give you the details, but once I saw somebody criticizing the reviewer very badly. Oh, this guy doesn't know anything about magnetism. But the reviewer was one of the Nobel laureates. So I would assume the reviewer knows slightly better than the authors. So you shouldn't make fool yourself by criticizing reviewers, because editor knows both sides. So be nice to the reviewer, especially if a reviewer misunderstood something. It is your fault, not the reviewer's fault, because you didn't explain it carefully. So make sure you revise accordingly so that the reviewer can understand what you want to explain. And also respond to all reviewers' comment individually, because sometimes we receive the author's reply with just generally saying, oh, we followed reviewers' comments and revised our manuscripts. But you should also highlight your corrections in your revision so that the reviewers can easily find out how the revision was made. So that basically gives a very good feeling to the reviewer. So that improves the relationship, definitely. And also, probably you think it is important to publish some of your works in a good journal, which normally means high-impact journals. And this is particularly true under the recent environment. If you want to get a good job, you need a certain number of high-impact journals. So I made some analysis for you based on some randomly chosen articles from Google Scholar. So this is the typical citation after the year of publication. The high-impact journals I selected for this analysis are Nature, PRL, Advanced Materials, and I didn't find good paper in science, so I didn't choose science, but those are the typical journals. And then if you fit this data nicely, and then you can find almost log-normal distribution. So most of the natural results can be fit by log-normal distribution. So you have very sharp peak, and then you have gradual decrease. So if you submit your paper in a conventional journal, and if your paper is not well written, and then you may end up with no citation. But if you write very carefully, and then the other journals have slightly different distribution. These are Journal of Applied Physics, JMMM, and JPhysD. I think those are the journals I selected, and I picked up some papers, and then, as you can see, in general, the distribution is the same. It's log-normal distribution, but it's got much, much longer tail, and the peak is more or less similar, depending on the quality of the paper. But that means, in the end, if you have a decent paper published in any journal, in the end, your citation, the number of citations, will be much more if you publish in rather conventional journals. I think this is mainly because quite a few people from industry or academia, they regularly read those JP, JMMM, or other journals. So your paper may be seen more by greater audience. So in the end, the number of citations may end up with more. So you can find your own strategy, because if you want to apply for a job next year, of course this type might work very nicely. But if you want to apply a job in 5 years' time, for example, if you want to apply for a promotion, and then this model may work better, because the peak position is around 7 years after the publication.